Hi, this is Techno I'm Connor. Today I'm going to show you how to make a AC to DC converter or a DC separator that makes a voltage. So first thing you're going to need is a circuit board made, or just like the whole sold ones. If you have one of those that wait on the shelf, you have to clean it with acetone. Just put acetone on a cloth and rub it really good. And just clean the copper underneath it. If you want to make a if you want to make a pressed circuit board, you can click the link. Alright. Now I'm going to show you how to make the circuit board. You're going to need 4 diodes and 1 capacitor. If you want to burn a LED, you're going to need a 10-volt capacitor. From 0 to 10, all voltages you have to use 10. Above that, you should use the closest capacitor. And the highest UF is the best, because it will separate the voltage the best. And it's the D-shower's time of it. The higher it is, the better it is. The AC electric is constantly alternating. It goes to minus to 0 to 0 to minus to plus to minus to 0. It constantly goes up and down. That's why it's called alternating current. In DC current, it doesn't go at all. It goes very little. In theory, though, it shouldn't go any at all. In the oscilloscope, you don't even see it. In the diode, what happens is as the electric goes to minus to plus, it separates them, because the diode only goes from one. It gets electric from one end to the other, and it separates it into that. And then when it gets from the other cable, it fills it up like that, and the capacitor will separate that, and the capacitor will get the to alternating completely off. Okay, so first get your diode, fold the legs of it, and cut it. Okay, now put it as you want in the circuit board. It may be a little hard because the holes are small on this one, but let me show you how I'm gonna draw it first. So the AC electric is going to go from the 2 sides, and the DC is going to come out the other 2 sides. Now, these are the diodes, so this is where it actually separates electric from the AC to DC. My drawing is not the best, but so as you can see, the diodes will get the electric and separate it to the both sides, and it will get UCOM. And then the capacity is in the middle. And the 4 diodes there will separate the electric from those sides for AC, and those sides will come out DC. Okay, now start putting in your diodes as in the drawing. Make sure to put the diode sides right, so the voltage will come out the right side. But make sure that you put them all equal, or else you may have trouble soldering it and spacing it. Okay, once you put them in, fold the legs of it. Okay, now you're going to put the diodes like this, and as you can see, I didn't do the best job, but and you can put the capacity in the right sides on the 2 the parts that come out DC, not where it comes in AC. So where it exits, you put the diode. Okay, you end up with something like this. If you want to learn how to solder a circuit board properly, click the link there. Okay, first clean the soldering machine. Get some flukes and put it on the circuit board. You can now put the flux on the circuit board, and flux cleans the tiny, dirts and rusts and everything. It's a very little acid. You can now just start soldering the legs down to the circuit board. You have to solder all the legs together on each side. Once you have soldered all of them, you make sure that all the legs are touching each other on each side. The capacity, make sure that the capacity is soldered. Now cut off the excess legs and the excess solder. Okay, now I have missed that dots. As you can see, they're both not touching each other, so I'm soldering them together. Okay. Now we just have to connect the electric. So those two sides are going to be AC and the other sides are going to be DC. I have an AC power supply. I converted it. There's usually AC-DC adapter. I made it an AC-AC adapter. So it's an AC. This gives out AC. So once connect your AC voltage to the AC. Well, because AC, there's no such thing as plus and minus. It doesn't matter how you connect it, but it'll come out pluses, minus. Lead, I'm gonna light a lead, which leads usually don't burn with AC, so I'm gonna prove that comes out DC. As you can see, the lead burns. I can't connect it right, yeah. As you can see, the lead is burning, but because it's not connecting right, yeah. As you can see, with AC electric, we're burning a DC lead. Now we have successfully converted a AC voltage to DC. Now let me show you how it's stable. As you can see, as I measure the voltage in the DC range, when you connect it right, you'll see that there's 2.99 volts. But if you touch it where the IC comes in, you'll see that you can't see it because it's in a DC mode. So that we have successfully converted AC to DC. As you can see in some new laptops, when you can plug in when the connectors are magnets, so when you can put it in both ways, which the plus and minus changes, but the circuit doesn't get affected, because if they put this kind of a circuit in it, which if you put in DC, it will always put out one side plus and one side minus when you put in DC. So this, let me adjust it to 2 volts, and here it will give, one side will always be minus and one side will always be plus. In this, you don't really need a capacity, but it doesn't hurt to have a capacity. Connect the DC however you want to, where the usually AC goes in. So when we connect the voltmeter to it, you can see that it always comes in 1 volt. It always comes in one side. So as you can see, the sides never change. always comes out of one side. So when we change the sides, it still will come out from one side. So when we get the lead, when I connect it to it, it will always come out, the lead will burn, even though if I change the sides. Now the lead is burning very little because of the capacitor is, because it's a 10 volt capacitor in DC, it's pulling too much electric, and it's you should get the volt a bit more for the lead to burn properly. I burned the tips of the crocodile when the crocodile holders went, and when I make the voltage more, as you can see, the lead burns properly because the capacitor is pulling too much. Usually LEDs burn at 3 volts, but as you can see in 4 volts it finally burns because of the capacitor. As you can see, even if I change the plus and minus sides, the lead will still burn because it separates the plus and minus. And you know that the LEDs are only one side. As you can see, when I change it from there, it doesn't burn. Okay, now we have successfully converted AC to DC, and DC, we separated the DC to plus and minus always. Thank you for watching.